Our speaker tonight is Eric Snodgrass, and he's the real deal, so give him a big round of applause.
I wish my wife would have been here to hear you call me the real deal, so that's not recorded, right? Okay, I'll just send that back to her. Anyways, thank you so much for the invitation to come out here tonight and speak. I'm excited about this. I love being in my home state speaking, and I got some great stuff to share with you tonight, and I'm going to kind of give you my end of the growing season talk. So we're going to cover a lot of what has impacted ag so far this year, and then we're going to talk about the all-important forecast for harvest, and then even take an outlook getting us toward winter to kind of discuss what I think might be happening, especially in South America. If you'd like to, everybody, you can all get out your cell phones right now, and I'd like for you to take a picture of this slide. Because when I get home tonight, I'm going to load this entire presentation to this web link. Which means if you want access to anything that I have today, you can get it all from this link. I'm also going to send this to Kim. Kim was here a second ago, but I'll send it to Kim. There she is. And that way you have access to it as well. But I was updating things in this talk up to the last few minutes just because that's how weather is. And so right there, ufi.box.com/v/polo. Try to make it as short as I could there. But anyways, that's my contact information as well. So, like I said, I'm pretty excited to be here. I'm also excited that I got to come here on a day that rained a little bit because we need this to finish this crop off and to continue toward this, what potentially is a record-breaking yield year here in Illinois for both corn and soybeans. So I'm pretty excited about it. I just want to show you something kind of neat. This is the view we had this morning of the storm system that's coming through right now. This is a map showing you water vapor. You can't see water vapor with the naked eye. We have to use a special sensor to see it. And this is the big, large, upper level system that's spinning that's going to give us multiple chances of rain over the next couple of days. This is the next one you got to watch. That one might be coming through over the next couple of days, which means you're not done. If you didn't get hit today, there's still multiple chances of rain that are going to come through here. I will show you through this talk how to access and use technology like this. So we will most certainly kind of get to that stuff later in the talk. And when you get home, or when I get home actually, I got about a 3-hour drive. When I get home and upload the talk, you can then download it and have links to everything that I shared with you today. Okay? So make sure that you have access to that. All right, we were talking over our table about kind of some stuff about technology, really about cell phones. And I think it's kind of funny we got in that conversation because when I think about the biggest changes that are happening in agriculture and the ways by which we can better mitigate and manage risk, I think about these technologies that are coming along. And it's amazing how much we can do, what we can access with a device in our pockets. But I saw this morning, and I kind of want to buy it. Are you ready? This is... Wow. Yeah, that is turning your cell phone into a bicopter, I guess, right? It's got two. I was blown away by this. That this actually. Now, what happens if it is miscalibrated? Your phone just shoots. I don't know. So when we use technology, we have to use it very carefully. That'll certainly be a theme for tonight. But I want to start off. We'll get off with this and get right into the weather. Okay. Now, when we think about the technological advances with weather, it comes in two different areas. It comes in the form of observation, and it comes in the form of prediction. And we are getting so much better at both. Every single year that goes by, I am continually impressed with the advances that are being made. It's interesting, though, when you ask any atmospheric scientist, who especially does a lot of work on computing, will still tell you this. We think that right now, the fastest computers on Earth, you'll see a simulation on one of them in a few minutes. The fastest ones on Earth are probably still 3 orders of magnitude too slow to do what we need them to do. So we need the pace of technology to continue. But look what we can do with our observations. This is how this season started. When you look at this particular picture, this was on Valentine's Day of this year. We had this big, massive circulation way up high in the stratosphere. This is 10 miles above our heads. And normally that is here. This is the polar vortex, okay? Every time I talk, I almost always have to talk about it. And it was displaced from its normal home, sitting here over the Arctic, and now slid over Western Canada. And this changed everything. For about 3 months, Because through the month of February, March, and April, the position of that polar vortex right there allowed for a lot of cold air to invade the middle part of this country. And it was interesting because the start of this season, every question that I was getting was, when are we going to get into the fields to plant this crop? Because not only did this displace cold air, you can see it in these two maps. The map that's on the top there shows you statewide precipitation ranks for February. And on the bottom, you have statewide temperature ranks for February. Now, when you look at this, the time period over which we have records only goes 124 years in the United States. So when you see that Illinois had its 124th wettest, that's the wettest we have on our record. It was also quite cool to our north and west. And when I was watching this, I'm like, if we don't have a pattern break, this crop is going to get planted very, very late into the season. So we kept watching. And as we watched, this system, well, it kept doing stuff like this. Let's fast forward now 2 months. This is April 16th. And on that day, we had this massive low-pressure system that started off in Colorado and went racing towards southern Wisconsin. And on the northern side of those big low-pressure systems in winter, we just get pounded with snow. So remember, April 16th, we're usually rolling planters around here. They were getting in parts of the northern plains here over 18 inches of snow. And then behind it, we had temperatures coming through that were not only below freezing, that's this black line, but in the single digits in the middle part of the country. You see, this is what happens when the pattern gets stuck due to something big like a piece of the polar vortex breaking off and staying in one position. April was the end of it, though. When you look at this, these are our statewide temperature ranks in April and precipitation ranks over there. And when April was all said and done, Illinois had its second coldest, with Iowa and Wisconsin at their coldest Aprils on record. And the question was, when and how are we going to get this crop planted? And these were all the things we were discussing. When is the pattern going to break? It broke at the end of April. And the whole trough ridge pattern, which we're going to talk about in a few minutes, shifted 1,000 miles, and all of a sudden we were planting like mad. At that moment, the concern was this. There was drought here, Panhandle, Oklahoma, Texas. In Amarillo, Texas, which is right here, it didn't rain at all from October of last year through almost the beginning of April of this year. That's 6 months of no precipitation at all. And I was actually in this building giving a talk last fall, and the question everyone was asking was, well, where's this going to go? Because drought in the Central Plains can and will move east. You should worry about drought here and here. These two regions are the most important regions for you to pay attention to for having drought invade Illinois. And what happens is when there's drought in the Central Plains, if it is not completely undone by spring rains, it migrates east. And therefore we get concerned about drought pressure here and heat here as well. But I tell people this all the time. I say, listen, spring rains can undo all of winter's sins when it comes to drought. And I say, if this map still looks like this at the beginning of June, then we have something to worry about. So we were paying attention. And May comes in like this. Look at this. We went from our second coldest April on record to our warmest May on record. And I grabbed this picture because I've never seen anything like it. That's a 160-foot wide planter. Okay? Because I kind of felt like this is what we were doing in the state of Illinois. Let me show you what you all accomplished, because I was blown away by this next statistic. This, you've probably seen these figures a million times. Planting progress for corn. 5-year average is the dashed line. Cold April put the 2018 season way below our 5-year average. We planted 70% of our corn crop in 2 weeks. That's almost 400 acres a minute. Way to go. Because when I go around the rest of the country and I tell them this, everyone's like, geez, those boys in Illinois. I'm like, yeah, we can really kill it when we need to and plant a lot of acreage. So I was really, you carried the country from this curve down here back up to that just like that. But this is what I had to pay attention to now. Because so much of this state was planted in that 2-week window. It was similar in Nebraska and Iowa, South Dakota, Indiana as well. It's also Kansas, Missouri. Everybody was planting rapidly during that time period. We just outpaced all of them. It told me that because the planting pace was so rapid right here, that this whole crop was going to come to maturity at about the same time. which means my forecasting efforts were going to be super focused on one very specific time period. And I had to be watching how May and June temperatures evolved to get us there. And so that's what we have to talk about. By the time we got through May, this was our concern. You see, once we got into May, we brought some precipitation to the regions that were dry. But we started to see drier conditions set up through the month of May right through here. Now, one, this allowed you to plant quickly, but two, if you weren't getting the rain right after you planted that, we would all desperately want. We started to see right here across this section of the U.S., drier conditions moving in. In fact, I bring up Normal, Illinois, and I do this just because McLean County, which has Bloomington Normal in it, is typically, every year, the largest producing county in the country for both corn and soybeans. It's just a big county with a lot of very, fertile ground. Look at this. They were in deficit. Going back from April 1st, this is all the way to the beginning of August here, you can see that from April 1st to June 1st, they were drier than it was in 1988. And a lot of people were concerned about this, which means at this point, the forecasting pressure on me was, are we going to go back to return to a pattern that has a lot more motion to it, a lot more waves moving through it, a lot more chances for precipitation? And at that point, we had some pretty good indicators that June was going to be warm, but also potentially very, very wet. And we're going to see that, what that looks like in just a few minutes. It all got started at the end of May, though, with this. This is Alberto. Pretty early in the season to have a tropical system come out of the Caribbean, go into the Gulf of Mexico, and straight up kind of the gut of the Corn Belt here, or at least the eastern Corn Belt. What was amazing was that on radar here, this is a radar image. This is in Indiana, so I live right here in Champaign, so this is the state line here, so this is Indianapolis. We're right between Champaign and Indy. It's amazing, you can actually still see the system had a pretty well-defined eye, but it was not spinning at hurricane strength, not even close. But this moved right over the region that we were very concerned about being very dry. And once that came through and put moisture into the soil, well, that changed the atmosphere and soil dynamics for the rest of the season. Because it went through and just soaked the ground, which means we had moisture in the soil to not only use, but also to evaporate and give us more thunderstorms later. Just to show you something neat, when you get this presentation later on this season when we're dealing with hurricanes, this website here is a fantastic one to go to monitor the track and position of these tropical cyclones. What's neat is when we model where we're going to predict these cyclones to go, we actually model them using a model that is run 51 different times. And when we run it 51 different times, each time with a very small change or perturbation, it gives us a spread over where we think the storm system is going to go. And using this technique and using the average, we can pinpoint down pretty well where these systems are going to go. And I want you to use this later on because when it gets toward harvest time this year, you know tropical systems can come right up the gut of the Mississippi River and cause problems for us. So we'll be watching stuff like this very, very carefully. Or by the way, if you don't want to watch it, I'll watch it for you, and you can listen to me talk about it twice a week for free. I'll show you how to get access to that at the end of this talk. So we'll be paying attention to that stuff. When that went through, look at the rainfall. This is a 3-day rainfall map. Alberto went right through here. And you can see that it brought a lot of rain into a section of the country that desperately needed it. From Peoria straight north to like Rochelle, Rockford area, right into here, this was a pre-cyclone band of rain that in some locations was over 5 inches of rain right in here. It got very close to where we are today with some heavy, heavy rain. And we just put all of that rain at this point in May on soil that has some of the best water retention in the world. And that set us up for a great start to the season. By the way, speaking of tropical cyclones, we just got an update from NOAA a couple of days ago. And because the season has already started off so far below normal, they've continued to give us a below normal forecast for the rest of the season. So a 60% chance of below normal, 30% chance of near normal, and 10% chance of above normal. But I'm going to tell you something. It only takes one tropical cyclone to make you forget this is what the forecast was. If one hits the wrong spot, or one like Hurricane Ike back in 2008 drops 6 to 7 inches of rain across the state of Illinois in September, it doesn't matter what they forecast. It just takes one to come through.
Do you feel Alberto changed the whole forecast for the spring and summer for us?
Alberto? Yeah, it did. So the question was, did Alberto really change the forecast for us? What it did was, it went right through a part of the country that has great soil that can retain moisture and dumped a bunch of water on it. And it was when the crop was small enough that the water got to the ground and was soaked in. And because that soil wasn't pan-hard dry, it was great moisture that would last us for a while. It's strange with seed technology, with the hybrids we have now, and the way that they use water. Events that in the past I would have thought would have really dinged yields pretty hard are not doing that anymore because of the way that the plants are using water now. It's weird. Trying to keep up with the pace of technology in ag is exhausting because of what seeds can do and what all that can do. It's amazing. But yes, it did. That came through that early, changed all of the atmosphere-land dynamics. We just call it that. That's the interaction between the heat and moisture between the soil and the atmosphere. Excellent question. By the way, today, you can interrupt me at any time and ask questions. Please do. That makes it a whole lot more fun for me and for you. So just shout out. Let's get them answered, all right? By the way, you want a little bit of weather 101 when it comes to hurricanes? Listen up. Hurricanes need two things really to form. They need warm ocean, really warm. Turns out we've done enough research to discover that if the ocean temperature is not at least 81 Fahrenheit, hurricanes can't form. Now, tropical storms and weaker systems can, but they'll never achieve hurricane strength if the ocean temperature is not at least 81. Here's the other thing. Hurricanes hate wind shear. Now, what is wind shear? It's a change of wind speed and direction with height. So it's kind of interesting. The hurricane itself loves to sit and spin violently in an environment that surrounds it that's perfectly still. So when it comes to forecasting hurricanes, that's all we really have to look at. This was 2017, around this time of year. Hurricanes are typically born off the coast of Africa. They come across what we call the main development region, and then they strengthen either in the Caribbean, the Western Atlantic, or in the Gulf of Mexico. This map shows you sea surface temperature, that's the skin temperature of the water, anomalies. So warmer than average. When they are warmer than average, look out. The ocean is ready to produce hurricanes if wind shear is low. Now look at this graph. See the black line? That tells me what the average value of wind shear is throughout the year. Hurricanes form during the low wind shear time of year. The blue line tells me what 2017 did. Way, way, way below average on shear. That meant the ocean was calm and hot, and hurricanes are going to show up. And this is what they did. This is Harvey. Hurricane Harvey, Cat 4, about ready to make landfall in southern Texas. It's about a day and a half away at this point from sitting over Houston, dropping 51 inches of rain. Now for perspective, Harvey, when it was all said and done, produced 33 trillion gallons of rain. Most of it on top of Houston. I'm 73 inches, so we're talking about that much rain in 5 days. That's 125% of your annual rainfall. Next, Irma. I can't believe this guy did this, but he decided to go outside in a 117-mile-an-hour wind. This particular hurricane went right up the gut of Florida. At one point, 20 million people did not have power. Because of this, there were 8 million households, 20 million people without power. And speaking of power, I don't know if you heard the news today. It has been about 11 months since Maria hit Puerto Rico. And they just today announced that they finally have power back on in Puerto Rico, 11 months later. And when you watch this animation, this particular hurricane right here had actually double eyewall in it. I have no more imagery after that point from the radar because 145-mile-an-hour wind tore the whole radar down. And they have still yet to replace it fully with the new WSR 88D radar. They added these up. They think the total is about $300 billion. And mostly that was taken on the chin by the reinsurance industry, which basically covers multi-peril stuff like this. Incredible to see that. All right. Right now, we don't have to worry about the tropics. Let's see if you've taken my lesson and learned something. So students in the back, here we go. Africa, main development region, Caribbean, Gulf of Mexico. Sea surface temperature anomalies. See the cold water off of Africa? No good for hurricanes. They got to have it warm. In addition to that, wind shear at times has been well above average. And there's been so much dust coming off of the west coast of Africa, it's actually made it all the way over, watch it again, to Illinois. We have a mixture in the air above us right now of Saharan dust and smoke from Canada and the western wildfires. That is why our sunsets right now are absolutely beautiful, because the air's dirty. The dirtier the air is, the more beautiful the sunsets are. When these hurricanes have to chew on that dust, it just kills them. And this is why the tropics are very quiet right now in the meantime. Yeah.
Is that above average?
Oh, that's well above average.
What causes that?
Basically right through here you have the trade winds. They blow right off the west coast of Africa. And they just pick up they do it all the time.
So
when you see these high colors in here, that's way above average. Yeah. I will do that all the time.
What influences the trade winds?
That's a good question. And if I had the answer to that question, I'd probably have some things named after me, okay? The question was, what influences the trade winds? We've been studying this, since the 1850s. That's when we started to discover global wind patterns. If we could fully understand all of the components that go into changing the strength and direction of our global wind patterns, our ability to predict the weather would be infinitely better.
Gulf Stream?
Oh my gosh, the Gulf Stream is just one part of it. I'll show you later all the other things I have to watch that continually affect it. But why the trade winds are so important is because ultimately the strength of the trade winds, not here, but the trade winds in the Pacific, are some of the most important weather features we have in controlling weather in the United States and in South America, the two largest grain producing places in the world. Because when the trade winds are really, really weak in the Pacific, we have El Nino. When they're strong, we have La Nina. And we are just trying to figure out still, in 2018, why did they speed up and slow down? So that will be a question we will come back to at the end. Excellent question about this. Let's come back to drought though, because this is our latest drought monitor. What I want you to see is this. The drought we had that started the season is gone in this area. It hit cotton pretty hard, but other than that, a little bit on the wheat here, but all the rains that came in late had a 5-class drought improvement. Where's it gotten worse? Look, it moves east, and that's where the drought has continued to develop. So this is what we saw so far this year in terms of our drought picture. Now, the U.S. Drought Monitor is a great resource. I recommend you all take a look at it. It comes out once a week on Thursdays. But you need to remember something about the Drought Monitor and the way our plants grow. The Drought Monitor is a cumulative data source. In other words, when you look at this, you are seeing a long-term effect on deficits of precipitation. Our plants don't necessarily behave that way. You could be in drought and have a couple of decent rainfall events that bring the plant back to life and will help save yields, even though you're still technically in drought. Because so much about what those plants deal with is topsoil moisture, whereas the drought monitor includes all of hydrology in it. So that includes underwater ground flows, that includes the water table, it also includes precipitation, runoff, evaporation, everything. So it's a great resource to be watching where long-term drought is developing, but in the short term, it will not reflect changes. It's the short-term things that really kind of impact the way our plants are growing. This is what's looked like so far this growing season. And I'm going to tell you something. For the last 3 weeks at every group that I've been speaking with, I've been telling them, and this is based off of a computer model that I run, to expect something around 178 as a yield. I am not a yield predictor, and in the past I've gotten it wrong. But this is why my model said it was going to be such a good year. This map, I love this one. I made this map where each circle is positioned in the middle of a county. And the size of the circle tells you that county's production. So the bigger the circle, the more it produces annually. Where we had moisture stress this year was here, some pockets of Indiana, and there, when you think about the Corn Belt. Now look at this. I'm talking about here, here, and there. The biggest corn and soybean producing counties in the country all had, for the most part, adequate precipitation. The blues on this map represent wetter than normal conditions from April 24th to August 14th. The red are drier. I have to go to Missouri. I am not looking forward to that talk. They are the one spot where the drought might be released and hammered this area. They have some locations in here look far, far worse than 2012 and 88 and all the worst years we have on record. But look at where it was wet. Right through there, over that time period, on the most productive counties in the country, and your soil, I know it's a small map, has some of the highest moisture holding capacity in the world, not just in the United States. And as a consequence, well, Illinois will probably hit a new record yield. The current estimates are 207. Some of the trade guys I work with up at Louis Dreyfus say it's going to be 210. They're preparing for the possibility of this being a 179, maybe even a 180 crop when it's all said and done, because of the forecast we're giving them over the next 2 weeks. The crop is going to finish fast. In fact, we should talk about that. By the way, just to show you how bad things are in Missouri, all of these pictures are from Twitter, so just so you know that. Nobody posts pictures of their best looking corn on Twitter, right? You only post the worst stuff, but this was in Missouri. I wasn't so much caring about these two pictures as that one. When I start to see stuff like this in the field, that tells me of bigger problems with soil moisture. That's a pretty large crack that's in the ground there. This was over in Nebraska. And the question here was, what is ear weight going to be? Because the crop is moving along so very fast. And so this guy was concerned about the size of his kernels and also how quickly it went to dent, and also like I said, what the ear weight was going to be. This was in Indiana. There are certainly some pockets of Indiana that are not in good shape, but I hate to say it. Hopefully nobody hears from Indiana. But if Illinois produces and Iowa produces, we don't really have to care about Indiana. It is the way it is, and everybody knows it. And they don't like it that I'm from Illinois when I leave here, because they know what we have and what we can do. By the way, if we became our own country, did you all know this? If Illinois was the country of Illinois, we are the 4th largest grain producing country in the world. Just the US, China, and Brazil beat us. And then we're Illinois, the country. Okay, let's not secede from the Union, no. By the way, this is in Michigan. I love this picture because Michigan was having some drought pressures earlier. But I guarantee you that that part of that field looks just like that every year. This is just a person like, I gotta make everybody think Michigan's bad. I bet this is their worst round. It never produces, but they have been dry there as well. So certainly that's been an interesting thing. This is what's the most interesting to me. That map is color-coded. I apologize, the numbers are so small, but that map is color-coding the accumulation of growing degree day units from April 24th, and I just picked that day as the start day of when everybody was planting around here, to present, or to yesterday. And when you look at it, if you had a perfectly normal year, you'd be right here in this white color. This year was a rapid accumulation of growing degree day units early in the season. We are currently in this section of the country about 400 growing degree day units ahead of average. That is about 2.5 or 3 weeks ahead for our corn crop. But it was interesting how the heat was delivered. Because when I make this map, and this map will next year be completely live on the web. I was testing it this year to see how well it performed. I make this map based on the corn calculation, which is a base of 50 degrees and a max of 86. And I do that because I'm trying to figure out where the heat is coming from. Now, as this crop came along and moved very fast, we kept getting our crop conditions report. I just want to say one thing about crop conditions reports. I've studied statistics, a lot of statistics. And for some reason, people put a lot of faith in these crop conditions reports because they look at the correlation between yield anomaly, higher than average yield, lower than average yield, percent of the crop ranked as good to excellent, and they see that the correlation coefficient, well, this is R squared, so R would be about 0.85. That's a really high correlation coefficient. So, wow, depending on what the rating is, if it's 72%, well, we should be expecting to be this far above trend. So just take a moment and look at this. If it is 72%, we've had years where 72% good to excellent gave us a 12 plus bushel on average. We've also had years where it was down 3. Don't use these because they're just not good for estimating yield. And Farm Doc Daily released some great information. From the first crop conditions report to the last one, they almost always drop an average of 5%. So you should expect everyone that comes out to continue to drop based on the first one. I want to at least throw that out there. But let's come back to the talk about heat. Look at these maps. This is now June. You've seen April, May, here's June. Maximum temperature ranks, 97. It got hot, but we did not see any scary upper 90s or triple-digit heat. Where did we get our heat? Overnight. And we talked about this at the table. We had warm nights in June and July. 122nd when it comes to our minimum temperatures. And that is where we accumulated the heat this year. Because I'm using a base of 50, we had a lot of nights where our overnight temperatures were in the 70s. And had we not had moisture, and had this number been higher, I think we would have really had problems with our yield this year. But instead we didn't. And the warm overnight lows just got the crop going really, really, really fast. So here is probably the most important meteorology 101 lesson to take away when it comes to heat. So if you've tuned me out, tune me right back in, all right? I went out and I made composite maps of our driest Julys since 1948 and our hottest Julys since 1948. And what you're looking at here is what we call a trough ridge pattern. Now, if you're ever listening to a meteorologist and they are not discussing troughs and ridges, then they didn't go to school to become a meteorologist. We are trained as pattern recognizers. That's all we're trained to do. And the thing we're trained to do is what Carl Gustav Rossby understood back in the 1940s. The atmosphere flows, and its flow tells you everything about what the weather's going to do at the surface. Here it is. When the atmosphere, in its flow, in the jet stream, bulges upward and northward, we call that a ridge. Sorry, north is that way, isn't it? Is that right? Okay, upward and northward, that's called a ridge. And when there's ridges, they block the flow of the atmosphere. They bring in heat, they bring in drought. When there's a trough, when the jet stream digs south, and the atmosphere is compacted and cool, we get unsettled weather, we get precipitation. There's a trough sitting over you now. That's what all of that stuff I showed you at the beginning was. And that's what brought in the precipitation today. Our hottest and driest years, look at this, I'll just draw it on the bottom, feature a trough in the Gulf of Alaska, a trough on the west coast, and a large ridge centered somewhere between Illinois and the Dakotas, between about 88 west and about 100 west, right in through here. And then it digs back into a trough just like this. So when there are extreme heat waves, so look at the opposite, when there are extreme heat waves in the northeast and in the northwest, we are typically doing really, really well. It's kind of like our economy, right? When the coastal economies are doing great or doing badly, we're having a good old time here in the Midwest, aren't we? Well, same thing, but opposite when it comes to the weather. When they're cool, and we have a ridge, our corn is going to be awful. To help you remember this, I decided to resurrect a video that I showed a lot in 2016. It's one of my favorites. Because on June 11th, 2016, we had this flow pattern. Now look, jet stream, trough here, ridge there, see it? Trough here. So there was a massive ridge in the northern part of the country. We saw triple-digit heat make it all the way as far north as Minneapolis. And the day that that happened, it was just one day, they got up to 100 degrees here in Minneapolis. Now, not only does this affect your yields, but it also affects the flow of traffic. Maybe some of you have seen me show this video before, but if not, it's one of my favorites. I'm going to show it again to everybody. Ready? Watch the first car. The ridge builds, the heat comes in with it. Watch the first car. Ready? Everybody see this? I'll go back so you can watch it again. I love this video. This is a giant buckle in the road due to 100-degree heat. And that's what ridges do. So if you're watching any of my weather videos from now on, and they are totally for free for you to watch, I will discuss this pattern. In fact, today at the end of this talk, we're going to talk about that. I'm going to show you where the ridge is going to be. Because when it's in place in our part of the country in July, this will destroy yields and your suspension, okay? So this is what happens, all right? Don't forget that. All right, here's the secret sauce. When you try to look for anything, you kind of brought this to attention a few moments ago. When you try to look for anything that is an indicator on what might give us an extremely hot and dry summer, it is hard to pick up on those indicators more than about a month before they happen, okay? In other words, if you find a meteorologist that tells you they know what's going to happen with great certainty 6 months before it happens and they got it right, it was an accident. I promise you. I have spent a decade researching this. Because when I figure this out, okay, I will no longer live in Illinois. Well, I'll live here part of the year. I'll also live in the Caribbean. I got it all picked out. So and I'm telling you this for a reason, because if we could accurately and consistently forecast long range 6 months in advance, we would absolutely dominate global energy and grain markets. And no one would know it except the super rich guy that's got all the money figuring this out. But I'm going to tell you something. Our atmosphere behaves as a nonlinear, chaotic system. And therefore, prediction, long range, is nearly impossible. We're getting better and better. But the statistical techniques that we need to use to forecast that far out require computing resources we don't have yet. But I'm going to show you what we watch. This map, if you go home and you remember nothing else, I want you to remember this map. Okay? So next year, when you are worried about heat in July, this is the one I want to come back into your brain. 70 years worth of statistics are in this map. 70 years. 1948 to 2018. What I correlated was heat right here with global skin temperature. That means over land, it's land temperature. Over water, it's water surface temperature. And one of the most defining characteristics that shows up is this. The correlation between cool water off of the Baja getting all the way into the Central Pacific and heat here is -0.6. And that, when you're doing a long-range forecast, is high. Therefore, every year, when it is June and we're trying to figure out if July is going to be hot, I watch this. Think about it. If it's cold there, we're going to have troughing here, which means ridging there and troughing over here. So we watch this carefully. Here's your proof. That's 2012. This is this year. I could go back to every hot, dry year that we have on record, and you will almost always see this feature. This year, it was a wash. It was even a little bit warmer than average throughout the month of July. Next year, when we get to June, I'll talk about that every single update I give, watching it carefully. Yeah?
Isn't cold water high pressure?
Yes, but the question was, does cold water mean high pressure? It does, but only in local circulations. Actually, it's what gives you sea breezes like they get in Florida all the time. But that is not the dynamical factor in what I'm talking about today. But you're right, it's just a different thing. So I watch this constantly, and that is one thing that I'll be paying attention to. So cold water's up the bottom, okay? You see them there? Remember, you got to see them like this. Don't look and just see one little cool dot. Oh crap, it's going to be hot. No, no, no. It's got to be this massive area of cold water extending off like this. That's what we have to pay attention to. So please remember that for next year. So let me show you the difference between 2012 and 2018. On the right, that's 2012. These are temperature anomalies. And on the left, that's 2018. And now you can see why that crop is out there. It was near average or cooler than average for most of this month. Look where it was hot. West Coast, Northeast, cool in the middle. 2012, cool on the West Coast, absolute scorcher in the middle. And I've been kind of joking because when I put this up on the big screen, doesn't it look like 2012 is smiling at you? Like you see the eyes? I don't know. It kind of looks like that to me. So when somebody says, oh, it's just like 2012, you're like, no, not even close. This wasn't like 2012 at all. All right, I'm going to skip this and get right to here. This was a new thing I saw this year. Did anybody spray paint their corn? Is this like a new thing for 2018? Okay. So when the plant was growing so fast this year due to all the heat in June, people would go out and spray paint, one plant and look at it 24 hours later to see how much it grew. So you can see that right in through there. I was really impressed by this because that's a lot of growth in one night, or one day, I'm sorry. By the way, this does not work. This is just, I thought that was fantastic. You will not get rust by spray painting with Rust-Oleum. And then I also saw this picture, which absolutely just cracked me up. This guy, Aaron, went out and spray painted his corn, which was completely destroyed by hail. This is not going to grow. It's going to continue to stay white. This one is done. So what I want to do is I'm going to take a short break in the middle of this talk and talk with you about severe weather. In one part of this middle part here, I really want to hone in on one thing that the National Weather Service has been begging people like us that get up and talk to people like you to do. So we're going to do that for a few moments here. But ready for this? Let's talk about severe weather. It's been a boring storm chase here. I storm chase as a hobby. We're at 63% of normal on tornadoes. We're at 73% of normal on hail. We're right about 100% of average on severe winds. Takes an inch or larger hail to get on this graph, 58-mile-an-hour winds to get over here, and any tornado over there. This has been a down year in terms of severe weather. Thankfully, I'm glad for this. Doesn't mean people have not been hit, but it's certainly been a record low year, at least over the last 10 years. By the way, this is kind of a funny story. When I was a little boy, about 10 years old, my grandma she lives in West Central Illinois. We're driving, we're in this little town called Chapin, Illinois. My grandma stops the Jeep we were driving in. She says, Eric, she goes, I want you to look right over there. And I look, Grandma says, look, okay. And I look over there, and there's a valley. There's a lot of rolling hills in West Central Illinois. And all of the trees have been ripped out of this valley. And I'm like, what is it, Grandma? She goes, Eric, 2 years ago, a massive tornado went right through that valley. I said, wow. And she goes, that's Tornado Alley. And I think I was in college before I realized Tornado Alley is not just in Chapin, Illinois. Okay? This is the whole thing. This whole area. And we actually have 2 tornado alleys. I don't know if you know this. This is the primary one. It goes just like this, Illinois to the Dakotas down in Texas. This is called Dixie Alley. Turns out Dixie Alley has more tornadoes than Tornado Alley does. So when you think about it, the southeast has the most. But here's what they look like. That's 60 years worth of tornadoes. How many of you have seen one? I figured a lot of hands would kind of go up here. Yeah, we have lots and lots of these things. And by the way, they do happen out here. There's just nobody to report them. All right, so there's certainly east of the Mississippi, quite a bit of them in there. Now, why do I bring up tornadoes? I bring them up to share with you some really awesome stuff. This is a simulation on one of our supercomputers at the University of Illinois, showing you what one of the storms looks like that makes tornadoes. Now, why show this to you? This simulation took all of the computing power of Blue Waters. All of it on the one node that it was operating on. And to create that simulation, this isn't CGI like you get in a video game. That's data-driven supercell. And why I'm excited? This will soon be in the weather forecast models that we all use every single day. The technology is getting to the point that we might be able to, at some point, 12 to 24 hours in advance, pinpoint severe weather risk from thunderstorms just like this. We cannot do it now, but we're going to get there very soon. The storm that you just saw in simulation looked just like this from the top. This was a supercell out in Wyoming earlier this year. The top of it called the anvil cloud. My dad used to call them thunderheads, okay? The anvil cloud spreading out here. That's what you flew through in the previous image. And a beautiful tornado that's sitting underneath it. I can call it beautiful because it did nothing in Wyoming. It just kind of sat and spun an open field out there. It didn't even destroy much in terms of crops or anything. You see, we're getting to the point where we're able to not only forecast these things better, but also detect them better. Here's a fun little history lesson for you. I've been sharing this story all fall. April 9th, 1953, Champaign is inside of this white blob. 2 guys at the Illinois State Water Survey named Glenn Stout and Don Staggs got access to a decommissioned ship radar from World War II. And they set it up just south of town in Champaign. What was interesting was, during World War II, weather was a nuisance to radars because you can't see the enemy through rain. But then we discovered, well, it's neat, we can see rain with these things. Let's start using them for weather applications. So we brought them back. The protocol was, if there was ever a storm nearby, shut the radar off, lower the dish down, and unplug everything. They didn't want anything to happen to the radar. So you can imagine that? Oh crap, bad weather, turn the radars off. That's what we used to do. But Don and Glenn decided to break the rules on April 9, 1953. They left it on. And as this is all ground clutter, the trees and buildings and stuff like that around Champaign. They watched this massive supercell thunderstorm produce that feature right there. And these were a series of Polaroids that Don Staggs took of the radar scope. And when he took them, he wrote on there, fish hook, and mailed them off to the University of Chicago, along with a lot of other colleagues of theirs throughout the country. Because the next day when they went out just north of town, right where that hook was located was a damage path from a tornado. Now what I love about this story is two things. They mailed the pictures first to the University of Chicago to a young scientist studying tornadoes by the name of Dr. Ted Fujita. Give us the F scale. And they broke the rules. And because of that, we started detecting with radar overnight, when you can't see them with your eyes, tornadoes. So rule breaking revolutionized severe weather detection. That's what modern Doppler radar imagery looks like. That's the hook echo on the tornado that you just saw. So now we color code these things, they're much higher resolution. It's just amazing to be able to see what we can do with this technology. You want access to the best radar data in the country, you can get it for free. There's a few great apps. My Radar is one of my favorite free ones, My Radar. But if you'd like to have the highest quality stuff that's out there, this was the best there is. It's called Radar Scope. Radar Scope. I'll show you that at the end of the presentation too. All right. In Iowa a few weeks ago, this is what some of the tornadoes did. Just want to show you how bad they were. Remind you of one thing. When tornadoes occur, how they kill you is with debris. And you can just see all of the debris that's in this particular tornado here in parts of southeastern Iowa. This was the other one. This is called the wedge tornado. It's one that is wider than it is tall. And this one went through Marshalltown. Look at what it did to the front bumper of that Toyota there. Now they produce very acute damage, right? When one goes through your field, it doesn't destroy everything, but it does damage just like this. So that's why typically when we're talking about ag weather risk, tornadoes are not really in the picture. Yeah, they'll destroy bins and barns and homes, but the probability of 1 square mile in Illinois getting hit by a tornado this year is 1 in 10,000. You're much more likely to not deal with this, sorry, forgot I threw this in here. You're much more likely to deal with hail and wind, but let me show you this. You know those fires out west? They've been spinning violently. This is called a fire vortex. And this is one of my most favorite videos I've gotten from so far this year, because that fiery vortex actually moved on over water. And look at this. About right here, it went from being a fire vortex to a water spout. And I've never seen that before. Thought you might like to see that. Those fires out west are unreal right now, by the way. We'll take a look at them. Yeah, what was that guy doing? Anyways, let's come back to the hail. Here's some hail damage from last year. These are baseball-sized hailstones. You can see what they did to these vehicles. This is this year. This is one of my favorite pictures. This is golf ball-sized hail on a golf course. So I thought that was entertaining. This is what a hail swath looks like from an airplane. You can see that there. This hail swath did that to that car in Colorado. And interestingly enough, this airplane flew through that. I don't know how that happened or why that happened, but I don't know how they even landed the plane. How did the guy see? You can't exactly stick your head out the window and see where you're going to land. Let's talk about hail for 2 seconds here. Ready? When you get your radar app, we specifically designed the color bar to have a break right there. When you see red, red does not mean tornado. Red only means heavy rain. Pink and purple and white, that switch in colors is where we indicate hail. This was very, very close to here earlier this season. You might know this guy, Bryce. This is just east of here. That was a storm that went through back, I forgot the day, but it was back in June. Produced that hail core and destroyed his corn. And when you want to forecast hail, when you download the talk, go to this website. They'll do the best job of it. Storm Prediction Center. spc.noaa.gov. They make maps like this every day. I'm going to take you back to July 29th. They were worried about this region right into here, gave it an enhanced risk of severe weather. On that day, the storms went rolling through, big ones, big supercells. You can see them up there on radar. Look, see the hail core in it right there? That was 70 dBz. The hail damage was so great that they could see it from space. Our NOAA satellites could see it from space. When it came through, this is what it did. Do you all see this in the news a couple of weeks ago? That was the hail that was in just south of Colorado Springs, going into I think that's the grizzly bear exhibit. See the hail core? Now you all know how to detect hail. This app, also when you're looking at it on your phone or computer, puts a bullseye right where you're standing. So you can see how close am I to that. That's why when I storm chase, my best friend is my cell phone. I don't take people with me when I storm chase. I go by myself with my cell phone. People have to stop and go to the bathroom, and they have opinions. I don't want to hear them. I would like to drive and see storms, so I use my cell phone. It keeps me out of the hail. Let's talk about winds real quick. Every chance I can to talk about, I got to do this. See those big long squall lines like the one going across Florida there? You need to remember this about squall lines. You don't want to be at the apex of the bow. Now, what the heck is a bow? See the storm structure I got in the upper right there? When these strong lines of thunderstorms tend to bend or bow, you never want to be at the point that they're bowing. It's literally like when a hunter draws back an arrow in a bow and the bow bends under the tension of the string. Well, the bending point is in the middle. And that's where the strongest back to front winds are located. When they come through, like these that went through parts of east central Illinois earlier this year, the leading edge of those storms like this can sometimes have wind speeds that exceed 70, 80, 90 miles an hour. This was only a 60 mile an hour wind that did this to this part of this field. Most of this guy's field recovered, but this section over here was green snap. It did not come back up. Leading edge of squall lines, strong straight line winds. By the way, did you all see this one recently in the news? That cloud feature you're watching over there is called a shelf cloud. That's your warning cloud. When that cloud, now that's a crazy one because it's actually almost touching the ground, but when that cloud passes over you, it's basically Mother Nature saying, hey, you down there, you've got 5 minutes before what's behind me is going to try to kill you with wind and hail and lightning. So take a picture, post it on Facebook, and get inside, and I'll download it and show it in my talks, okay? This was right here in the leading edge of this storm. You see this little fine line right here? That is that. So straight line wind damage. Now that can wipe out a field. This is the most common type of severe weather in the United States. Straight line winds. But the National Weather Service says you take 5 minutes of every talk and address this. I really need the men in the room to listen up. And hopefully you know why. Do you see the figure over on the right? That is male versus female fatalities from lightning. 80% of lightning victims are males. And we're not going to have a discussion as to why. But I'm going to tell you, gentlemen, there's a free web source that you can use that will tell you where lightning is. In 2014, I'll never forget, June 25th, 2014, I got a phone call from my mother telling me my dad had just been struck by lightning. Now, my dad was not doing what men are typically doing when they're struck by lightning. He was actually running out to get the car for my mom. It was her birthday. He was going to take her to breakfast. And while he was running around the side of the car in the rain, lightning struck a tree, went right down the tree into his leg, threw him 8 feet. Now, Mom thankfully called me once everything was okay. But once I knew Dad was okay, and by the way, 90% of people that are struck survive. Don't pretend you're going to remember that statistic. I want you to think that every time you're struck, you're going to die. But 90% of people that are struck live. I went out to this website, Blitzertung, that's German for lightning location, and I saved off the data for where my dad was struck in northern Wisconsin, a little town called Minocqua up here. And I'm like, Dad, this is the one that got you. So, men, there's a resource that will tell you where the lightning is and how it's coming toward you. Use this. Your lifetime odds, 1 in 8,000 of getting struck, by the way. Anybody here been struck by lightning? Usually we have a couple when I give talks been struck. Okay, it's all right. I may not want to reveal that. Your odds of getting struck this year, 1 in 700,000. Now, just to let you know, you live in a part of the world that gets a lot of lightning. That's all this map says. So this is a real weather risk for the rest of your life. To show you what it looks like, check this out. My goal behind doing this is to scare you, by the way. So my computer's plugged into the power outlet over there. I'm guessing it's 110 volts with 15 amps, right? That's a pretty standard outlet. You just saw a negative polarity lightning strike over here, shot at 9,000 frames per second. This is a pretty impressive camera. When that lightning strike occurred, it delivered 1 billion volts and 30,000 amps. You see these three here going the other direction? Those are called positive polarity strikes. We typically measure them at 10 billion volts and 300,000 amps. If one of these gets you, you don't survive. You can probably survive this. At least most people do, as long as it doesn't hit you right here or it crosses your chest. But you see this little tower right here? It's actually going to get struck 16 times.
If you are a slow blinker, you would have missed everything in this video. The whole video in real time lasts less than 1/3 of a second. Lightning strikes every single day on the Earth average at 9 million strikes per day. And in addition to humans being in trouble, like if a tree gets struck and it comes down the side of the tree, by the way, just let's get this out there. If there's a thunderstorm, I would rather have you standing in the middle of an open field, crouched down low to the ground, than standing next to a tree. Trees get their own category. 15% of fatalities are next to trees. And by the way, the tree can either kill you by electrocuting you with the lightning in it, or it might blow up and impale you. So you have your choice, electrocution or blunt force trauma. By the way, check this one out. This was in Chicago a couple years ago. Lightning struck that pole right there. Watch it again in slow motion. Just completely destroys it. Have I done my duty to the National Weather Service? Please, we're really, really trying to get these statistics down, men and cows. I'm sorry, I know you just ate, but you need to know this too. Because you now know where you can get free lightning data, if there's anything you can do to protect, especially your livestock, do it. If you can get them into a barn or get them away from trees or off of fence rows, because what do? They go up here to the fence, they eat the really good grass on the other side, the lightning strikes the fence and gets them all. Or they stand there at the tree, ground strike goes into the tree, gets them all. The cow cannot do what you can do, and this is what you can do. You can put your feet together. See, that's everything. If lightning struck that speaker right there and the energy went into the ground, let's say it put 1,000,000 volts into the ground there, it will radiate outward, and it decreases in intensity the farther away it gets. If I stand right here like this foot will be at a higher voltage than this foot. And I bet every single one of you in here has put up an electric fence at some point. You know they work on voltage differences. If my feet are at different voltages, it will drive a current through my body. And the hope is it stays in my legs. I don't want it to come up and go anywhere near my heart. That'll disrupt the signal between my heart and brain. If I put my feet together, they're now at roughly the same voltage. This is why you don't lie down, you don't run if you think you're going to get struck by lightning. What you should do is, you know the safest place to go when there's lightning in the nearby area? Where do you think the safest place is? Y'all need to know this. Get in a car. Cars are very protected. They act as Faraday cages. Lightning strikes the car, inhabitants are typically very safe. Now, this does not work if you have a convertible. I saw a few up there. And it certainly doesn't work if your car is made of carbon fiber. If you've got that much money, then you need to be aware of this. But get into a car, safest place to be. If you can't, and you think you're about to get struck by lightning, put your feet together, crouch down low to the ground, just like this, as low as you can go, and you wait until it goes away. Now, what is it that goes away? Does anybody know what it'll feel like if you're about to get struck by lightning? Your hair will stand up. That's real, because the electric field underneath the storm is as high as 3 million volts per meter, and your hair will stick up. And by the way, if you're bald, trust me, you'll still feel it. Okay. Lightning. Can we change the statistic together? I hope we can. All right, let's finish up this talk, all right? I want to get now to finish the growing season, give you the forecast, talk about some major shifts that are happening in agriculture, and then if you would like to, we'll take some time for questions at the very end. What you got here is a forecast, not a forecast, but a map that shows you the previous 2 weeks of rainfall up until yesterday. And this is the concern. I'm running my finger over some very productive ground that over the last almost month has been relatively dry. You had plenty of moisture in the soil going into this drier time period, but it's been pretty dry right through here, and you're about right there. So when we look at this, the concern was, are we going to get rain in that area? Because we need rain here to finish off the bean crop and help finish off the corn crop. In the last 72 hours, well, this was made this morning right before I left, we were getting precipitation coming through this area. And as it was coming through, we got quite a bit of scattered showers and thunderstorms here. We're not done yet, because the system that's over here that produced this is on its way toward Illinois as well. We're going to look at that in the forecast in a few seconds. But the markets are watching this very carefully. They ask me about it, so I know they're watching it. So that has been their biggest concern. By the way, I found this morning. Where's the lousiest weather in the United States? This is fantastic. Where's the best weather? People are like, well, where is the best weather in the country? I was like, well, I'll tell you where I'd love to be a weatherman on TV. It's San Diego. You kidding me? 300 days a year of sunshine. I just wake up and go on TV like, yeah, it's going to be 80 today, 60 tonight for the next month and a half. It's not so easy to forecast in through here. The worst weather, though, in the U.S., if I got my colors right, I think is right up here, unless you go to parts of Alaska, which are way worse. But I thought you might like to see that. But let's talk about forecasting it. This is all the stuff that every time I produce a forecast, I look at. And you need to focus on the graph that's in the middle, because we're going to do a forecast for the remainder of my talk. Our ability to forecast the weather, this is forecast skill and lead time. We're really good at forecasting the weather like the day of, but that doesn't really help a lot of you out. Look at how quickly our forecast skill drops with time. We call this area in through here no man's land. This is what I've spent a decade researching. I'm trying to take this curve and move it from there to there. Because if I can better forecast this, I can better help you all plan your operations. If I could forecast that 20 to 60 day time period better, I could better help you plan your operations. What are the tools at our disposal? We have a series of short-range weather models. We have weather models that run out about 15 to 16 days. We can run these models in an ensemble mode. You're going to see all of this in a few moments. We then, when we talk about our long-range prediction, we can use teleconnection. So you were asking about the trade winds. The trade winds control this and this. All these other ones are controlled by the jet stream. And these are all just nerd acronyms that I use all the time. But ENSO is probably the one you want to know the most about. That's El Nino and the Southern Oscillation. Down here, these are our seasonal models. They are not good. None of them are. But we'll show you what they look like. And a technique that's probably the most challenging of all of them is what we call an analog forecast. That is where I look at the current conditions of the weather right now and search historically for the best match. And then say, okay, well, what happened in my best match year after that time period? And I'm going to use that to forecast the next little bit of time. This is why, honestly, you should spend most of your time in your forecasting right in here. Because the science that drives the forecasting out this far is just not there yet. And that's why I told you, if you're a meteorologist, it tells you that they know the weather in 6 months, and they get it right, they were lying. When they get it wrong, they never tell you, right? We had a company a few years ago that this really bit them. Do you all remember Weather Trends 360? Remember when they came out in April and said, hey, are you ready for $7.50 corn? Well, first of all, who's not ready for $7.50 corn? Second of all, they said it was going to be a huge drought in 2016. They based all of it off of a time series analysis, which is not good meteorology. We don't teach our students to do just one technique. And what ended up happening? Well, 16 at the time set a record. By the way, just so you all know this, if you want $7.50 corn, you know what has to happen? You all have to have problems. That's it. It's when this state and Iowa are having problems that corn is driven up that high again. So that's something to think about here. All right, so this is what our models can do. I have a link to this you can download, or you can look at later on when I post the talk. It's right up there. You want to see these animations? Go out there and go to that website. This was the forecast by our high-resolution short-term models today. So I pulled this off early this morning at 7 a.m., and this was the forecast for the day. Big blob of rain here. If you watch the radar at all today, it happened. Scattered showers around this area. Some of you got rain today. I know, I drove through some of it, but it missed a whole bunch of you as well. This was the HRRR, High Resolution Rapid Refresh. This is the NAM, North American Mesoscale Model. Very similar short-term forecasts. You can use these out to 3 days every day. If you wake up tomorrow and you're like, I got to know what I'm going to do for the next 3 days. What's weather going to do to it? Go to this website, run these animations, and see. That's what it'll tell you. It'll tell you when what the rain is going to be, what the temperatures are going to be, all of that stuff. I'm just showing you precipitation right now. It's right there. When you download the talk later, the website is right up here at the top, okay? Free access to this because you pay for it. Your tax money pays for this. Beyond it, let's look at the big stuff. Before I get into it, these are the 4 places around the country that run high-resolution, long-range forecasts. And when I say long-range, it's day 0 to 16 days. The Europeans have one called the ECMWF. The US has one called the GFS. The Canadians have one called the CMC. And the Brits have one called the UK Met. The Canadians, I'm sorry if any of you are Canadians here, but they really suck at this, so don't use their stuff. The best in the business is the Europeans right now. And here's the reason why. In the United States, our model is a phenomenal model, but it's paid for with taxpayer money. And therefore, the incentive to continually improve and make this a better and better product is not there. The ECMWF is a privately owned entity. And therefore, the business decisions that they make and the contracts that they take in is how they invest in making their model better and better and better. You see the blue line? This is a skill graphic. See how the blue line is almost always on top? That's the performance of the European model. If you watch my weather videos, I have been discussing for the last 2.5 weeks how low predictability is right now. Every single major global model took a large downward trend in its predictability. And the problems are right here, and there, and there. This is in the Pacific Ocean. When the Pacific Ocean gets active with typhoons, it changes everything for the United States because we are downstream of the Pacific Ocean. It's upstream from us. Our weather comes from the west. And all of these features are continually perturbing, changing the flow of the background state of the atmosphere. And when they do that, it messes everything up, and it reduces predictability beyond a few days. I do have some good news for you. Thursday night, that trough I pointed out that was over Montana will be right here and sweeping through Illinois. The trough gives us our next chance of precipitation. Then, Sunday morning, I will be watching another one, and it's going to sweep across the state of Illinois. We still have 2 more chances, one at the end of this week and one on probably Monday or Tuesday of next week. I think we're going to get a decent weekend out of this, on either side of it coming through the area. Now, what is it doing for us? Well, I'm only going to show you the European model. Why? Because it's the only one that's performing well. This is what it's doing. This was the forecast starting at 7 p.m. last night. And this is the forecast for the next 10 days. And I'm just going to tell you something. When I have phone calls, and I have many of them every week, with some big commodity trading firms, they ask me about this. Do I trust that map? You see, this map is what happens when we run the European model 51 times and average what it says. You see right in through here and right in through there, and the whole of the Corn Belt is forecast to have, well, to be above normal in terms of precipitation. When the commodity traders sniff rain, you know what it's going to do to the markets. In fact, back before we had kind of ubiquitous weather data all over the place, there used to be a saying, right? If it's raining in Chicago, the markets are going to tank. That's where they're doing the trading. Well, now it's a little bit bigger than that, but they're talking about this. And because of that map, bringing very wet conditions here and wet conditions here, they're seeing right now that there's nothing that makes them fear that this crop won't be as big as USDA just said it is, because it's way ahead. Usually at this time, you know what they're asking me about? Are we going to get those September rains we need to finish the bean crop? They're not even talking about September rain anymore. They don't even care. The crop will be done before then. That map right there is the most important one I think I'm going to show you today. And unfortunately, the only way you'll be able to access that for free is if you watch my free weather videos. You can pay for it, though. It's $100 a year to have access to this website. Now, my company who's going to buy the data for this, it's $250,000 a year for us to access the data. The GFS is free because we paid for it. We're taxpayer money. But the superior model is right there. Now, is this model nailed the precipitation? Should you expect right here 2 inches of rain over the next 10 days? No. This model is not going to pinpoint that exactly. Widely scattered showers and storms, at least twice in the next 7 days coming through the area. It's hit or miss. It's not everybody gets a drink. But this is at least showing 2 chances of the rain coming through. All right. Pattern recognition. Are you ready? Blue are troughs. Red are ridges. Watch this. Trough, 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 big trough. Ridge nearby. Here's what the forecast is going to do. It's the 30th of August. Where is the heat going to be? Somebody tell me. Yeah, on the coasts. We have had this stubborn ridge out west, and they're burning because of it. And right now, all the way through the end of the month, there is no reason for us to be fearing extreme heat. Look at what the model's saying right now in terms of temperature anomalies. This is a sliding 5-day window. Where's the heat? On both coasts. Now, is this model perfect? No. How long do I trust it? Probably only 7 to 10 days. This went out 15 for you, though. 7 to 10 days is all the longer I'm trusting this model right now, but that's what it's showing. Expect mid-80s, maybe some upper 80s, but the chances of 90s, or even something getting deep into the 90s, is pretty low at this point. Ridges are out west, and the west is burning. Here's some of the images from space we've got of those fires. That was the Carr fire. By the way, the one that's burning now, I forget the name of it, begins with an M. It's the largest fire in California state history. It's like 600 square miles of fire. By the way, on top of these big smoke plumes, you can actually produce clouds. That's called a pyrocumulus cloud. There's a cumulus cloud on top of a smoke plume. Amazing to see that. There's some new research that's getting published right now where they're calling this change that we're getting in California the California whiplash. So they went back and analyzed about 50 years worth of data, and what they've discovered is California's tendency to go back and forth between flood and drought is getting larger and larger and larger with time. These were the Santa Rosa fires back in late in the year 2017, which were awful. Same area having massive mudslides just 3 months later. Each one of these a $1 billion disaster. California, by the way, there's 40 million people. They produce, or they lead the nation in the production of 40 different fruits and vegetables and milk. And just to tell you how much stress they put on their water resources, I met a farmer in December of 2017 when I was out giving a talk in Las Vegas. He stopped the whole talk and got up in the middle and told me something. He goes, listen, you're talking about how bad it is out in California. He said, I'm going to tell you, I'm from California. He's got 5,000 head of cattle, and he's got a 2,500 acre farm where he just cuts his corn for silage. He said, we have to irrigate everything out there. He said, I dug a well. I put in a bid to have a well dug in 2015. Hasn't been dug as of December 2017. And he said, my deposit was $500,000. And he goes, you want to know the kicker? And I say, what is the kicker after that? And he goes, the kicker is the estimated well depth is 2,000 feet. So in addition to having stresses from precipitation, they are also having stresses in terms of reducing the water that's in their reservoirs and in their aquifers. So you've got to be watching California for these reasons. Do they lead in corn and soybeans? No. But in 40 other fruits and vegetables and milk, yes. So it's important we pay attention to them. Going on from here, I want to show you this. Now, I know it's pretty deep in the evening. You're like, are you serious? You show me a graph like that? Yes, listen, okay? Remember troughs and ridges? Okay. June, July, August. Let's average all 3 months. Each year going back to 1948. When you look at this figure, this is a year of a lot of ridging. This is a year of a lot of troughing. So when you look at it like this, these are cool years and warm years. Because of the cooler weather we had in the 60s, you can see an upward trend in the Midwest since then. But if I didn't show you these data and started in the 1970s and went forward, our trend is flat. Yeah, year-to-year variability is high, but our trend is flat. What's the significance? That is the Western United States. What this means is the upward trend you see in that dotted line means that during June and July and August, the Western United States is seeing a higher frequency of ridges. And what happens when the West burns? We have good weather. Now, I hate to say this about people in California and Oregon and Washington, but we love it in the Midwest when they're on fire. Because if they're on fire, there's a ridge. If there's a ridge there, there's a trough here. So, pay attention. Next time California is really, really hot and dry, I bet you're doing just fine here. Next time California is really, really cool and wet, we're having problems here. That is very important to remember. Their trend is up, ours is flat. You want to know what climate change really looks like? I know you hear about this from a lot of politicians. I have no political bent on this at all, so don't even think that I do. I'm just going to show you data. Here's how climate is changing in Illinois. 1948 to present, this is statewide, I'm sorry, not statewide, this is Corn Belt minimum temperatures, Corn Belt, try that again, maximum temperatures, minimum temperatures, average. We are not seeing an upward trend in our average temperatures. We are not seeing an upward trend. In fact, we're seeing a downward trend in June, July, August, high temperatures. Where's the change? It's right there. We have warmer nights here. That's our change. You live in one of the most insulated places on the planet when it comes to climate change. And this figure right here is why production agriculture in this state under a changing climate is going to thrive. If you're not thinking entrepreneurially about climate change, you are missing the boat, because this is a positive thing, because it's going to take another 3 degrees of warming at night before you even start to get into the realm of stressing your corn and soybean crops overnight. And that's a half century away. I don't get to share that story anywhere else in the world. Everywhere else I go to talk about issues with changes in Earth's climate, it's never positive. You live, because of the Great Lakes and the fact there's no mountains north or south of you, in a perfect place in the world to continue kind of with business as usual in terms of agriculture. We're going to reap the benefits of this. You had a question?
Corn changing climate.
Well, the question was, how is corn changing climate? There was a massive change back in the 1800s when we drained the swamp here and put corn in. But I don't have data from the 1800s, early 1800s, to tell you what it looked like. I can tell you this, though. We'll come back to those two figures. I want to get to this one, okay? From Texas to Nebraska, there's the Ogallala Aquifer, and the Rocky Mountains are right here. So because the air flows from west to east and goes over the Rocky Mountains, by the time it gets on the other side, we have what's called a rain shadow. We squeeze all the moisture out on this side of the Rockies and the Sierra Nevadas, and then it's dry here. There's almost always been this common knowledge that the 100th meridian marked the end of the rain shadow, to where you can get a lot of tropical moisture that gives you thunderstorms here. 70 years worth of data have showed us that that 100th meridian boundary is shifting east. And part of that is due to the changes we've seen in agriculture in the middle part of the country. One of my favorite books ever to read is called The Worst Hard Time. It's about the Dust Bowl of the 1930s. And it talks about what happens when you have a 10-year stretch of no precipitation in this area and the stresses that it puts on the Ogallala Aquifer. Aquifers take centuries to recharge. They don't recharge with every rainfall. So as we continue to put pressure in this part of the country, and this is a part of the country where there's a lot of irrigation, the shift of the 100th meridian boundary to where it's becoming more arid will change the crops that are grown here. And we benefit from this. Think about it. They grow a lot of corn and soybeans right in through here, and a lot of wheat. If they're not able to successfully produce those crops, that makes Illinois crops so much more valuable. And while they are getting drier and drier and drier, we're getting the opposite of this. This is what we're getting. Okay, the funny video first. This was in California. That's a Lamborghini Gallardo. Don't drive in floodwaters. That's the moral of the story. Okay, ignore the video. That's the other part of the story. We are getting, there's been a 37% increase in our large rainfall events in the state of Illinois. We're still on average. You all want to watch the video, okay. For everybody else, listen. We're still getting about 40 inches of rain a year right in this part of the country. But the delivery is changing. We're getting our rainfall from big events followed by longer dry stretches. We have soil that can handle it and seed technology that's keeping up. But that is the biggest changes we're getting. So while they are drying out here, we are actually getting a whole lot more precipitation. We have an upward trend in our precipitation in spring and summer. And that means the climate shift that's happening in Illinois is making it better for us to grow corn and soybeans here. By the way, talking about corn and soybeans, want to know where they're going? North. That map over there, 2011 to 2016, shows you the change per county in soybeans. Corn looks exactly the same. Where are they growing a lot of it now? The Dakotas. I went back and redug up the data that Farm Doc Daily produced here. I just wanted to prove it to myself. Look at this. This is change in soybean acres from 1990 to 2018. North Dakota, South Dakota are the two largest peaks. And they're growing it up there because they have had, on average, a 10-day increase in their frost-free season. In Fargo, by the way, from about 70 to present, there's been a 30-day increase on average in their frost-free season. They can now get a full variety, a full season bean crop in there. And it doesn't just stop there. This is Canada. So look at this. 1998 to 2018 acreage for soybeans. It used to just be they grew them in Quebec. Now they grow them in almost every province except for British Columbia and the Northwest Territory. So they have they've almost tripled their amount of soybean acres in Canada. Now, just for perspective, where would Illinois be on this chart? Go 3 million above that. So they're growing like 2/3 of Illinois beans in Canada. So you're far more important than they are, but that's change, something to pay attention to. All right, to wrap this up, by the way, just so you all know, I put that video in here for a reason, the Lamborghini, because of this. Flood victims, 2/3 are driving. That means when people are killed in floods, there was a decision involved. So don't die from lightning or drive into floodwaters. If you leave here today remembering that, at least save some lives today, all right? All right, by the way, you asked about precipitation. That's the trend. See it? Up on precipitation, up on overnight low temperatures. Until those overnight lows get to be stressful, you're going to reap the benefits of this. All right? I'll point out one last thing before we talk about South America and wrap this up. I'm sorry, I'm long tonight, but you got to know this stuff, all right? Where will we be this year? Right up here. UD trend this year, these 2 years and these years, average yield is 180 bushel an acre for the country. Just so you know, that's not that far away. But dips like this occur when the jet stream flows like that. Trough there, trough here, ridge in the middle part of the country. Even with the stuff that I just told you, you still have large annual variability, which means another 2012 can most certainly happen. So don't think that those won't ever happen again. It's just the longer term trends are what I just shared with you. All right, let's talk about the rest of the world, South America, and we'll be done, okay? Where's our pressure coming from? Yes? Solar flares. So a lot of people like to talk about solar flares as a technique to forecast with. So what is it? Well, really, I think what you mean is sunspots, right? So on the surface of the sun, we have occasionally these spots that show up that are a little bit cooler than the rest of the surface of the sun. They're still about 4,000 Kelvin, which is really hot, but the rest of the surface is about 6,000 Kelvin. Whenever they show up, actually the sun is more active. It's sending much more energy to the Earth. The sunspot cycle is on a really nice 11 and 22-year cycle. When you correlate that against our temperatures and weather patterns, there is really no correlation. I know there's a lot of meteorologists out there that like to use those as a part of their forecasting techniques. I don't. And it's only because I've looked at the data and I can't find a reason to use it. And by the way, the fluctuations in the total amount of energy that the sun gives us is around 0.5 watt per meter squared. Now, if that number doesn't mean anything to you, every single square meter of the Earth that faces the sun gets 1,370 watts. So the fluctuations are kind of in the noise. But you'll hear a lot of meteorologists talking about those things. I'll just tell it to you this way. There's not a single faculty member on my staff that teaches about it at all in our classes. For a reason. Oh yeah, you know what it messes with? Excellent. What it messes with is space weather. Yeah, there's a whole thing called space weather. And why this is important is because when we have these massive solar flares, it disrupts our communications. So what I'm scared about with it is, we've had in the past massive solar flares, big eruptions, they're called coronal mass ejections. And when they happen, GPS systems don't work. So if you're out driving your tractor and you're running on GPS and that gets disrupted, you can't drive the tractor anymore. communicate. This is not a cell phone, but whatever. It can mess up cell phone communications, all sorts of stuff like that. Oh yeah, that's real. That is definitely real. But the relationship to weather is completely different. I'm glad you asked that question. It's an excellent question. Let's do this. Europe. This has been good for us. Iberian Peninsula, that's Spain, hot, dry. France, very hot and dry. Germany, massive drought. The UK drought, parts of Poland drought. We've had spotty drought and heat throughout the season in the Black Sea region, which is right in through here. And the Russian wheat belt, by the way, well, this is a map we get from our satellites. What you see here is the Russian wheat belt this year doesn't look nearly as good as it did a year ago. And we love that. Let's let them have all the problems in the world. That makes our grain so much more valuable. Those are the regions we're seeing stresses on this year. By the way, for the next week in Europe, they are forecast dry and hotter than average. So we're at the end of the season and they're still having problems in Europe, and that's not going away. Here's the last little bit I want to talk with you about. Big time long range forecast. This winter, we're going to be watching for the development of a weak El Nino. That's when the water temperatures in here are warmer than average. Should you care about this in Illinois? Not really. If it was a strong El Nino, yeah, but not when they're weak like this. What we're going to have to worry about here is South America. So this is the forecast right now for South America, long-range forecast. Remember I told you about those long-range models? Here they are. These are the 8 models run in North America all put together, and this is the European model. And the color coding on here is precipitation anomalies. So wetter than average under the blues, drier than average under the reds. What you want to remember from this slide is this side over here, because this is actually summarizing it. When there's an El Nino, northern growing regions and the Amazon tend to be dry. Southern growing regions in Brazil and Argentina tend to be wet. Flip the whole thing over for La Nina, okay? This is October, November, December, so the start of their growing season. This is October, November, December, January. The only consistent thing that I see on this is that in each one of these, they've got Argentina with a wet bias this year. Now think about last year. Last growing season, Argentina had La Nina conditions, and it was the exact opposite. What's the take-home point with this? I think the big thing to think about as we finish this whole talk up is this figure, because now we're almost out of the growing season in the US. What are we doing in South America? See that black line? Don't forget that one later either. That black line shows from 1977 to 2017 how the number of acres for soybeans has been changing, and these data come from CONAB. The slope on that line is to the tune of 600,000 hectares per year. So that is what? That's about 1.4 million acres, right? Is that about right? 600,000 hectares, about 1.4 million. Okay, so that means every year Brazil adds about 15% of Illinois soybean acres. 15%, and we lead the country, okay? Why should you care? Their production curve is exponential. So even if El Nino shows up and causes some stress in Mato Grosso, the northernmost state where they grow a lot of soybeans, that's actually what's shown to you there on that map, and they take a 10 or 15% hit on yield because they are currently projected to have 5% more acres in Brazil for the 2018-19 crop, they'll still have their second largest crop ever. And that is an advantage that Brazil has over the rest of the world. They have more acres every single year. Don't forget that either. The El Nino that's developing could possibly cause some drought stress in Brazil. And where it's going to cause it is right here. This is what deforestation looks like. That's from Google Images. The fields you see cut into the Amazon here, they started to be prepared back in the late 1980s. They're just now coming into production because it takes a long time for them to get the soil acidity just right to grow soybeans. But this is the frontier of agriculture on the planet. And they've got a lot of land they can continue to turn into soybean fields. So we're watching this carefully, and brand new research has just started to see how deforestation, to have the land put into, to become ag productive, is going to impact what ultimately gives them their rain, which is the Brazilian monsoon. We don't know yet what the shifts in deforestation will do to the strength of that circulation, but we're trying to figure it out. Now with that, I will stop and take questions, but I always get asked, what are my favorite resources? Well, you can access my weather videos completely for free. I'm making one tonight when I go home. Agrible.com. You can sign up for free to get access to my weather videos. They're about 10 to 15 minutes long, and I talk about the weather like I just talked about it right here. If you'd like to start accessing this stuff all by yourself, you'll see this tonight when you download the talk. Tropical Tidbits is free. Pivotal Weather is free. It takes a little bit of time to get used to these two websites. You want access to the European model, you have to pay for it. It's $100 a year on this site. That's the cheapest site there is. Check out these two as well, weather.gov and SPC, that's Storm Prediction Center. I like those as well. Is there a good weather app out there? There's not. But I like these. I like Dark Sky, Weather Underground, and What the Forecast. That's kind of a fun one. Get What the Forecast when you read it. Anybody have this on their phone? Good. It'll swear at you and tells you what the weather is, but it kind of yells at you when it does it. Tone it down. You don't have to leave it on like full-fledged swearing, but whatever. It's funny. It's actually running off of the Dark Sky API. Radar Scope, one-time $9 fee on your phone. Best radar app in existence. You will not find a better one. My company has 2 free apps that are totally free, no obligation. One's called Pocket Rain Gauge. It'll tell you in the last 24 hours, wherever you are, how much rain fell. My phone's over there. So you can check that one out. Pocket Spray Smart. What this one does, again, totally free, is it will tell you what the wind speed is, where you're located, what the temperature and relative humidity is, and also if there's a temperature inversion present right there. I helped develop this app, so I know exactly what's in it. And these 2 apps, totally free, no obligation. You just download them for free from either the Android store or the Apple store, and you got them. But these are the weather resources that I like to use all the time. But again, I'll tell you about it for free twice a week if you want to just go check out that website up there. Okay, we went way long, but great questions. I think you had a lot of good stuff here. But I'd be more than happy to take questions from you all right now. Who has a question for me at this point? Or are you all just blurry-eyed and want some chocolate? Or go ahead, yeah.
Dry weather in the north correlating to early frost.
Oh, excellent question. The question was, is dry weather in the northern part of the state, or in the northern U.S., going to correlate with an early frost? Thankfully, the answer is no. There's no correlation between those two things. In fact, the drier weather there might actually lead to more ridging in the north as we go into fall. But I've looked that up. There is no correlation between those features. I wish there were. It'd make predictions so much easier. Excellent question. Another question. Yeah. Yeah. Question was, how do we monitor the trade winds? I'll tell you one that I really like here. I think I should be connected to the web. Let me bring up my brightness a little bit. There we go. So a website that I like here is this one, earth.nullschool.net. And when you look at this, if it downloads the data for you here, you'll be able to see what the winds look like across the whole planet at any given time. Might take a minute to show up here. The other site that you can be using, I'm sorry, it looks like it's just taking a little bit of extra time here to... Yeah, there is. But it's a little bit trickier to learn to use. So remember that website I told you about, Tropical Tidbits? Well, this is what it looks like. And if you come over here, you can click on, you can either look at analysis tools or forecast models. And when you do that, this is a great website, you can select a region, and then you can choose where in the world you want to look at. So if you're interested in the North Atlantic, I'll click right here, and it'll change my view to the North Atlantic. I'm sorry, it looks like my connection's a little bit slow here. I can say, well, show me mean sea level pressure and 10-meter winds. So these are the winds just off the ocean surface. And it makes maps that look just like this. And what's nice about it, and it's slowly loading. I just think it's because we have a slow internet connection right now. You can slide this across and see 15 days worth of forecast. So there's Ernesto. Who really cares? It's like, we call them fish storms. It's not going to do anything. And you can use this to gauge the speed and direction. You can also get a little fancy and use the ensemble, to look at them as well, which will give you the deviation from normal. But that's the website I want you all to get used to trying out. By the way, the kid that made this, it's hilarious. He's from Alaska, but he wanted to study tropical weather. Imagine that. So he now lives in Florida at Florida State University and built this whole website. It has taken me 18 months to build my prototype of this. So this kid is a computing genius. I tried to hire him, but he wanted to finish his education first. I'm proud of him for wanting to do that. But anyways, we'll have actually our own website like this on agrable.com that'll be free to everybody as well. And I actually give all my dates and times specifically, in Central Time, not Zulu time, which is what they do. That's what weather models are all in. So this is 12Z. That's noon at the prime meridian. That's 7 a.m. local time. So just something to get used to. Excellent question. Any other questions for me about this? I know we're late in the evening. Oh my gosh, GOES 16 is incredible. This new satellite we have up there, we launched it about a year and a half ago. It is revolutionizing weather detection and prediction. Thank goodness we spent the money on it. In fact, I'm very happy with Donald Trump about two things when it comes to weather. One thing is he has invested in weather prediction. So he has given money to NOAA to improve our prediction. And the second thing is he just made one of the best hires that I could possibly imagine. He hired a guy by the name of Kelvin Drogemeyer, who's a PhD from Illinois. He's his new science advisor. And that guy, I know him. I'm not going to lie to you, I didn't read it, but I've thumbed through his dissertation. It's 800 pages. We keep it in the department as like an icon of what dissertations should never be like, because it's 800 pages. And this man is a brilliant scientist, and I'm very proud that he is now serving as a science advisor to the current administration. So that's a good thing. So,
Eric,
yeah, thank you.
thank you.
Yeah.
Everyone give them a round of applause.